So, hello everyone. Now we'll move on to our next problem, which is exponential 2. It's a slight variation of the problem. In the previous problem, we have calculated a to the power b, but now we have to calculate a to the power b to the power c. Let us see how we can approach the problem. So, what are the common mistakes when we calculate a to the power b to the power c? What anyone can think, like we can declare any variable x where it will save b to the power c, and after calculating b to the power c we will calculate a to the power x, which is b to the power c, and print the result. But this is totally wrong. Let us see in which test case it will go wrong. Let us say a is anything like 2 and b to the power c is coming out to be 10 to the power 9 plus 7. Right, it can happen because b and c are pretty large enough, and at last we have to calculate b to the power c modulo 10 to the power 9 plus 7, so it will come out to be 0, right? So our approach will be x will be come out to 0, and x to the power a to the power x, that it is a to the power 0, will come out to be 1 in our approach. But what's the actual value of a to the power 10 to the power 9 plus 7, or 2 to the power 10 to the power 9 plus 7? It's not actually 1, but it is equal to 2. So by doing this, like, we will first calculate b to the power c and then substitute this value to the power of a is totally wrong. Don't think like this, because modular arithmetic didn't work like that. So what you can do, you can use Fermat-Little theorem. What the Fermat-Little theorem states, that a to the power p minus 1 modulo p is equal to 1, right? So you can see the proof of this theorem, but it is not required for the CP algorithms. You should know the what's the final statement, because it will eventually gonna help you. So see, we want to calculate a to the power b to the power c, right? So anyhow, can we convert b to the power c to this p minus 1, because anyhow we want to calculate a to the power b to the power c percent p. Our p is 10 to the power 9 plus 7. So what if we consider b to the power c as p minus 1 into some quotient plus r? So you know that any number x can be written as quotient into dividend plus remainder. So likewise, I have written b to the power c as quotient q into dividend p minus 1 plus r. Why we have considered p minus 1? Because we want to make this power of b to the power c in terms of p minus 1, because it will eventually gonna cancel when we take modulo with p, right? So what this will become, this will become a to the power p minus 1 into q plus r. So what we can write it, so it will be a to the power p minus 1 into q plus into a to the power r, because you know that a to the power x plus y is nothing but a to the power x into a to the power y. Similarly, I have split it. Now as we know that this is modulo p. So this will be also modulo p. So in multiplication we can directly split this modulo operator in each terms. So it will be a to the power p minus 1 into q modulo p into a to the power r modulo p. And we know that a to the power p modulo a to the power p minus 1 modulo p is nothing but 1, so it will be 1. And we know that p is 10 to the power 7 and value of a lies between 0 to 10 to the power 9, so a is always less than b. And when we take modulo of a number greater than that number, so it will always come the same number. Like if we do 2 to the power 5, it will always come out 2 because 5 is always greater than 2. So the expression comes out to be a to the power b to the power c is a to the power r. So what is r? R was nothing but the remainder of the b to the power c. Now how we can find the value of r? This is the main question. So now for finding the value of r, you can think like, we know that if we take modulo in each side, eventually we want to calculate the value of r. So if we take modulo p minus 1, so this term has a factor of p minus 1, so if we take modulo p minus 1, it will eventually give you 0. So why so? Because let us say we have 2 into 3 and we are taking modulo 2, so it will always gonna cancel this, and remainder we will always have 0 because it will divide the number. So now this will be r modulo p minus 1, and p minus 1 is still greater than r, so it will be r. So what is our r? R is nothing but b to the power c modulo p minus 1. So now we know the value of r. We can calculate b to the power c modulo p minus 1, and we can put that value into r and then calculate a to the power b. So this is the overall conclusion. I will show you the code. Firstly, I applied the naive approach, then I come to realize that this will never gonna work. So this is the same function. I have just modified it by including the mod operator, because first when we will calculate b to the power c, we have to pass the modulo operator as mod minus 1, because the value of r is nothing but b to the power c modulo p minus 1. So p is here mod, and after calculating that r, this is r, we can calculate a to the power r percent modulo. So this is the accepted code. You can ask me any doubt if you having query. So thank you for watching the video.